Okay, so now we're on to the second video in the series, and I just want to review some translation of algebraic expressions because A, this is used constantly in word problems, and B, the other thing that's real important about this is that we do have a test that will be coming up in the not too distant future. So giving you the opportunity to review the material between now and then puts you in great shape to do on the test. I had a great guy teach me how to coach baseball. His name was Tommy Grimm, and he used to tell us all the time, the more you make the game like practice, and the more you make practice like the game, the more successful your team is going to be. So if we constantly weave in things like fractions, things like percents, things like math terminology, algebraic expressions, evaluating expressions, equations, etc., that gives us a really strong foundation from which to prosper. Okay, so let's have you write some phrases of these things on paper. Do stop and start. I'll fill them in. Okay, there's your first answers. The sum of a number and 4, x plus 4. Sum means add. 2 more than a number. Don't forget, more than, less than. Last shall be first, first shall be last. X plus 2. The last 2, the first 2 goes to last at the end, and the number at the end goes to the beginning of the x. 5 added to a number, x plus 5 or 5 plus x, either way. A number increased by 7, x plus 7, because to increase is to add. And a number plus 3, well, that's kind of self-evident, x plus 3. You could also use n for all of those. Okay, now let's work on some difference ones, some subtraction material. Go ahead, give it a shot. Stop and start again. You may hear my dog in the background lapping up water. She is doing that in the room at the moment. That is not me drinking from the dog dish. All right, so here's the correct answers. Difference between a number and 2, x minus 2. Compare that with the next one that says the difference between 2 and the number. So when we read this word difference, we don't change the order. The order stays, the word order matches the algebraic phrase order. 2 fewer than a number, that's like less than, fewer than. 2 fewer than a number means we start with the number, then we go 2 fewer, so that's x minus 2. 5 less than a number, fewer than, less than, last shall be first, first shall be last. The 5 goes to the end, minus 5. Number goes to the first, x minus 5. A number decreased by 7. Start with the number, decrease it by 7, x minus 7. 8 minus a number, okay, you're going to start with the 8 minus the number, subtract it, 8 minus x, and a number minus 3. That would be x minus 3. Little stop and start here for multiplication. Okay, 6 times a number, 6x. Product of 4 and a number, 4x. And again, you can use n for all of these. Twice a number, 2x. 25% of a number. This is one that we did mention back when we gave words for multiplication, but we hadn't done an example of it yet. Now we can. 25% of a number. You must convert that percent to a decimal. That's why it's 0.25. And of means multiply, so 0.25x. Last but not least, division examples. Go ahead, stop and start. Okay, number divided by 8, x over 8. The quotient of 5 in the number, you're starting with the 5, 5 divided by x. The quotient of a number and 5, x over 5, because you're starting with the number. And last, reciprocal means flip it. So the number would be x, flip it 1 over x, or n again, any of those. All right. So now we want to do some new terminology and get you comfortable with it. And there are some matters involving consecutive integers, okay? So let's talk about consecutive. What does that word mean in the English language? Consecutive means in a row. Very good. So for example, 3 and 4 are consecutive integers. A little later on, it says consecutive even integers. That would be like 2 and 4. 2, 4, 6, 2, 4, 6, 8. Then there's consecutive odds. 3, 5, 3, 5, 7, and so on. And that's what consecutive even and consecutive odds are. So for consecutive integers, here's an example. For example, 5 and 6. Now, what algebraic expression would match up with that? So when we don't know what something is, let's pretend or assume we don't, we're going to call the first thing n or x, or another letter if you wanted to. But the key is, how do you go from one consecutive integer, like 5, to the next one? You go up by 1. So the algebraic expression would be x and x plus 1. And we will do lots of word problems that say, find 2 consecutive integers. So what you're going to have to do is remember, oh yeah, consecutive integers, well, that's like going from 5 to 6, which means you go up 1. So if the first one's x, the next one goes up 1 to x plus 1. Now, instead of 2 consecutive integers, what about 3 consecutive integers? Well, 3 of them in a row would be like 8, 9, 10, okay? And if the first one's x, well, we already know what the second one is. That's x plus 1. But the third one would be x plus 2, okay? Now we'll do 2 consecutive even integers. An example of that, 6 and 8. And how would we set that up? So if the first one's x, to go from 5 to 6 in the first example, or 8 to 9 in the second example, we went up by 1. To go up from 6 to 8, do we go up by 1? What do we go up by? 2. So it would be x and x plus 2. Now, and that kind of makes sense, right? Because we got consecutive even, and that goes from 6 to 8. So even, you go up by 2. Consecutive odd integers would go from, say, -5 to -3, or say from +7 to 9. But the thing that can be a little bit tricky here, unless you think it through, is that it is also x and x plus 2. Whether you're going from an even integer to the next even integer, you have to skip the odd in between. And if you're going from an odd to an odd, you have to skip the even in between. So in either case, whether you're doing consecutive even or consecutive odd, you have the number that you start with, the x, and then you're going to skip a number and then choose the next one. So that's why you're going up by 2s. So whether you're doing consecutive even or consecutive odd, you go up by 2s. All right? And next one up, 3 consecutive even integers. Again, consecutive even, so you're going up by 2s. And this time it's 3 of them. So, for example, 2, 4, 6. And what would it look like in an algebraic expression? X, x plus 2, x plus 4. Good. What about consecutive odd? For example, 3, 5, 7. Well, the consecutive odd in the algebraic expression sense will look exactly the same. Just like evens, you're skipping numbers. So it's x, x plus 2, and x plus 4. Now, as far as strategies for word problems go, you know me, I don't like to get too hung up on the formal. I like things to be comfortable and natural to kids. So you definitely want to read the problem, a couple of times until you get comfortable with it. That's the first thing. Use a variable for the unknown. That's pretty simple. Forget step 2. Cross it out. All right? All we want to do for step 2 is you want to underline or highlight, emphasize anything in that word problem that you think is important. Now, unfortunately, I can't highlight in PowerPoint without doing too much stuff. So I'm going to verbally highlight, and then you can use a marker or a pen to underline on your own. Next, write an equation in terms of x, okay, that models it. Solve the equation. So you already know how to write equations. We've been doing that. We just reviewed some of it. And you know to read the problem over. The big thing here is we want you to learn how to underline or highlight, because then you want to use each of those pieces of information. And that's how we set this up. So let me give you one example before we go to the next videotape. Maybe we'll even do a couple of examples, okay? 4 subtracted from 6 times a number is 68. So with your pen, and again, I apologize that I couldn't do this in the program. 4 subtracted from 6 times a number, that's important. 4 subtracted from 6 times a number, so underline it. Is important, underline it. And 68 is important. Now what you need to do is use every piece of information. If you use them all, then you'll get it right. If you think about it, there's people that sit there and get paid a lot of money in the state to write out these questions to give to kids. So when they write out the questions, they say, what's it important for the kids to know? And they include everything that's important. So if they think it's important, you better catch on to that. And the way you do it is by underlining it. And then you don't have to read the whole problem every single time and feel so lost. You just need to focus on what you underlined. And I'll show you how you focus on that. From the part that said 4 subtracted from 6 times a number, there it is. 4 subtracted from, remember from goes first, 6 times a number, 6n minus 4. And then the is always equals, and then 68. And then once you write it out, you just go to solving equations the way you know how. Okay? Adding 4 to both sides, 6n is 72, divided by 6, n is equal to 12. And this is so important. If you remember on the very first day that we started doing equations, we said to you guys, you don't want to say to yourself, 4 subtracted from 6 times the number 68. What number could that be? Oh, what number? Oh, let me think. What number could that be? We said, no, we want to develop a strategy. And the strategy is to get letters on one side, numbers on the other, and to do the inverse operations of whatever's going on. And that's what we did. It says minus 4, we did plus 4. It says multiply by 6, we did divided by 6. And when you do that, you're like the detective at the crime scene working through the crime, revisiting it, reverse engineering it, so then you can get the equation correct. All right, we're going to stop at this point with this particular video, and then we'll go and launch ourselves into a bunch of word problems.